Okay, girls, I'm going to draw the electron configuration of aluminium and see how that relates to its position in the periodic table. So let's start by drawing the electron configuration of aluminium. Okay, so aluminium is here on the periodic table and it has the atomic number of 13. So that tells me that aluminium has 13 protons and it's in its ground state here, so no charge overall, so it has 13 electrons. Okay, so let's draw it out. Aluminium, let's find a home for its electrons. First shell, 2 electrons. Second shell, 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we've got 13 in total, so we have to keep filling these shells. So we're up to 10, so we've got 3 more to go. 1, 2, 3. Okay, hopefully everyone's okay with doing that. Now let's just have a careful look at this diagram and how it relates to this periodic table here. Alright, so these things called valence electrons. These are speaking about the electrons which are in the outermost shell. So we can see that the third shell here is the outermost shell. So the electrons in this shell are called the valence electrons. So these electrons. So how many does aluminium have? Aluminium has 3 valence electrons. Okay, so how many shells in total does aluminium have? It's got 1, 2, 3, so 3 shells in total. Alright, so let's just have a look at aluminium and its posi on the periodic table. So it's in group 1, 2, 13. Okay, this can also be called 3. Now, how many valence electrons does aluminium have? It has 3. So that is why it's in group 13 or group 3, because it has 3 valence electrons. So say silicon here, it's in group 4 or 14, it has 4 valence electrons. Carbon has 4 valence electrons. This element here has 4 valence electrons. Boron has 3 valence electrons. Aluminium has 3 valence electrons. This element here has 3 valence electrons. So if you're in the same group, you have the same number of valence electrons. So group 1, all of these elements have 1 valence electron. Group 2 have 2 valence electrons. Group 3, all of these elements have 3 valence electrons. Group 4 or 14 have 4 valence electrons, etc. Okay, so aluminium, group 13, it has 3 valence electrons, as we saw when we drew it out. Okay, now what row is it in, or what period? So 1, 2, 3, it's in the 3rd period. Now, periods are arranged in terms of the number of shells that you have filled. And what are the total number of shells that we said? We've got 3 shells. So that is the reason why aluminium is in period 3, because it has 3 shells in total. So sodium has 3 shells in total, magnesium has 3 shells in total. Okay, all of these elements have 3 shells in total. So that's why they're in period 3. These elements here in period 4, all of these have 4 shells in total. All of these elements have 2 shells in total. Okay, so before I end the video, I just want to show you boron, and we would expect boron to have 3 valence electrons, wouldn't we? So let's just check that out, and by drawing boron. So boron is number 5, atomic number 5. Okay, so that tells me that boron has 5 protons and it has 5 electrons. So let's draw it. Boron, symbol is B. Where its electrons, it has 5 in total, so 1, 2. Still got a few more to find their home. 1, 2, 3, 4, 5. And that's it. Alright, so how many valence electrons does boron have? It has 3. Okay, how many total shells does it have? 2. 1, 2. Alright, so it has 3 valence electrons, so we would expect boron to be in group 3 or 13. Now, is it? Yes, it is. It is in group 3 or 13, okay, because it has 3 valence electrons. Now, it has boron has 2 shells in total, 1, 2, so we would expect it to be in period 2. Now, is it? 1, 2, yes, it is, okay. So groups, same number of valence electrons. Periods, same number of total shells. So I'll just write that down. Groups, all elements in the same group, same number of valence electrons. Periods, same number of total shells.